All right, video 4 is going to be on angle addition and bisectors. So we did some work with basic angles in the last video. We got some practice with that. So in this video, we're going to talk about some special types of angles and just some different diagrams that we're going to see throughout the year. So angle addition, this first example here is very similar to the segment addition that we dealt with. But again, very important that we can label and fill in the necessary parts. So for our first question here, we have angle ABD, which is going to be this angle here, ABD. We're going to fill that in. It's 3x plus 15. We have angle DBC, which is going to be this angle here, 2x plus 10. And the last one is angle ABC, which in this case is going to be the whole thing. So this entire thing is 95 degrees. And what we want to make sure that we understand, at least what we're capable of here, is visualizing that these two smaller angles, the 3x plus 15 and the 2x plus 10, when I add them together, they make up this 95. That's going to help us set up our equation. So the question does say what's the value of ABC. It really should just say what's the value of x, because we know ABC is 95. So we're going to set up 3x plus 15 plus 2x plus 10 equals 95. We got our line down the equal sign, combine like terms. 3x and 2x is 5x, 15 and 10 is 25. And we are going to solve this two-step equation here. All right, we should get x equals 14. All right, if we wanted to find the two smaller angles, we could plug the 14 back in for x, but we're not going to have to do that for this question. All right, so being able to set up these equations, very important, just like the segments that we learned in our first two videos. All right, so now just like midpoint and segment bisector, we do have something called an angle bisector. So an angle bisector is a line, array, or a segment that divides an angle into two equal angles. So again, very, very similar to midpoint and bisector. The key thing to remember here is we have MO bisects LMN. So again, this is what's getting cut into two equal parts. Remember, we wrote it down in the last video. MO cuts LMN into two equal angles. So if this is LMN, then we know that O is right in the middle. All right, so what I usually do to label this is I would mark that this angle is congruent to this angle. All right, and we can set up our equations. We can write it out if we want. I would probably call them 1 and 2, and I would say angle 1 is congruent or equal to angle 2. It's probably the easier way that I would set this up, or at least I would write it out. All right, so let's go through some examples. I think I have 3 questions for us to go through here using angle bisectors and angle addition. All right, first one. If EC bisects BED, what are the values of the missing angles? So when I see this here again, EC bisecting BED, what I want to think about is if this is BED, I know it's getting cut into two equal parts. So if that is 35, then this must also be 35. And then if we want the whole thing, it should be 70 degrees. That's really all you have to do for this one. We don't have any algebra necessary. Right. Example 2. Again, start with reading and seeing where our bisectors are and what information that they give us. So if MH bisects angle MAT, again, before I even read the rest of the question, what I know is MAT is being cut in half or into two equal parts. So I know that these two are the same. Now I can read the rest and fill in what I need to fill in. So MAH is 3x plus 15. That would be this small part here. And then HAT is 5x minus 5. Now, since these are equal, right? Or congruent because of the word bisector. Just like midpoint, we can set these two equations equal to each other. We're going to subtract 3x from both sides. I'm going to add 5 to both sides. We get 20 equals 2x. We get x equals 10. Now, the question does say solve for MAT over here. So what I have to make sure that I do is I take this 10 and I plug it back in. It's going to give me 45. So this is 45. This is 45. The whole thing would be, or MAT, the whole thing would be 90 degrees. The whole thing would be 90. All right, again, key thing going back to that one, bisector, knowing which two pieces are equal to each other and setting things equal. Now, as we get further along this year, the diagrams are going to get more complicated and the wording is going to get more and more. So this one doesn't have a lot of algebra in it, but the visual of this question is a little difficult. So we're trying to take it one step at a time. If BC bisects AEC, so what I would look at here is AE, and C. So I know that BE is cutting that angle into two equal parts. So I know that these two are the same. All right, and then if you keep reading, we have EC bisects BED. Now, this is a little trickier because it's on top of what we've already drawn. So now this is another bisector, which makes this angle equal to this angle. So this is already a little bit confusing, but what's really happening, if you're looking at the markings, this blue angle is congruent to this blue angle, and then this blue one is congruent to this green one. All three of these are the same. So as we start to kind of plug things in, or as we start to write in the information, it will hopefully make a little bit of sense. So angle CED is 35. CED is right here. So if this is 35, then this has to be 35, then this has to be 35. So that's really all of our missing angles. If we want, we can start to add things together. It would be helpful to kind of know some of the other pieces of information. Like if you wanted to know AED, this whole angle, we could add up the 35s and get 105. What we could also do is find some of the smaller angles. So I know it's going to be a little tough with the drawing on here. I'll see if I can get a different color. But if we wanted something like AEC, like this one, should be able to find that measurement, again, being those two 35s. So angle AEC could be 70 degrees. Now, this is where things get a little bit confusing. You really have to make sure you take your time, you label. If you have to draw things out separate, you can. We'll have some things in class that you can use, like some trace paper. So we could draw out like the AEC with the B separate if we needed to, all right? And then we can kind of work on this diagram separately. So for some people, that's more confusing. For other people, that's helpful, all right? But we got some practice questions in your packet, all right? So we're done here for this video. Get on those practice questions, get ready for that mastery check, and I'll see you guys in the next video.